Thank you so much. I am honored to be here. And as Shukla said, I'm interested in making history usable. It's not just science that needs to become usable, and how can history be usable to scientists? So the focus in our conversation so far today has mostly been on what would be new about Eve. And that's a lot of fun to talk about. Kind of like watching Star Trek is fun, and it's also a good way to win funding. But as I think the only historian in the room, I want to invite you to take part in a thought experiment with me. So let's imagine a historian 200 years from now, assuming our species makes it that far. Suppose this historian wants to write a history of efforts to understand the Earth's climate. So, our future historian, what might she say about Eve? I think this is a good thing for, all of us to be thinking about. And if scientists like to talk about what's new and unprecedented, historians are in the business of proving them wrong. So our historian of the future will undoubtedly find continuities where we're talking about the discontinuities. And so far, we've talked about climate science as synonymous with computers and satellites. We've talked about the blue marble as the dawn. And a, quote, global consciousness. I'm actually going to argue the opposite. Prioritizing consensus, I think, is out of step with both good science and with the pursuit of justice. And so my historical research suggests that the roots of modern climate science lie not far from here geographically in what was, in the 19th century, Austria-Hungary, a political entity that has been compared to the European Union for its commitment to the cultural autonomy of its 12 official linguistic communities. It's often assumed that the Austro-Hungarian Empire was already an anachronism in the 19th century, a multinational state in the era of nationalism. Recent historical research shows otherwise. The 19th century Habsburg state created a legal space in which even former serfs could assert their rights as citizens and pursue economic development. My own research has shown that this multinational state was equally dynamic scientifically. So in the middle of the 19th century, an influential set of imperial and royal scientists, as they identified, set out to document the Habsburg state's vaunted diversity, natural as well as human. In doing so, they confronted their own challenge. How could they represent local differences while producing a coherent overview? This problem stimulated innovations across a range of media. I'm going to show you some examples from cartography. So these will be maps that made novel use of color to illustrate the demographic and climatic diversity of the empire. So this is a very famous ethnographic map of the empire, which is a landmark in the history of cartography for its visualization of demographic diversity. This is a map from 30 years later, 1888, of the floral regions of the monarchy. Here we have the distribution of heat in July from 1886, the distribution of days with storms, and the distribution of rainfall. When taken up by physical scientists, this problem of representation, of bearing out monarchy's motto of unity in diversity, inspired some of the foundational techniques that modern climate science has used to think across scales, as worked out by Habsburg scientists like Julius Hahn, Max Margulis, Albert de Font, and Wilhelm Schmidt. Among the solutions they came up with were Schmidt's Austausch coefficient, a measure of turbulent motion applicable to flows of any dimension. So when applied to movements of air perpendicular to the ground, Austausch was of great practical value for characterizing the localness of a climate, for instance, for agricultural purposes. But Austausch was equally applicable to studies at the hemispheric scale to quantify turbulent exchange between the equator and the poles. Another example of research coming out of the Habsburg Empire was the concept of available potential energy due to Max Margulis, which played an important part in the first general circulation models of the 1960s and 70s and remains important to the analysis of the instability associated with baroclinic zones, as you all know. This research tradition transformed the very meaning of climate. Previously understood as regional in scope, climate became a concept applicable at multiple scales from the local to the planetary. Until the 1890s, the general circulation of the atmosphere had marked the limit where climatology edged into meteorology. But in showing how to apply a climatological tool like Austausch on the scale of the atmosphere as a whole, Habsburg scientists identified the general circulation as an object of climatological research. They gave substance to the notion of the planetary climate, the Weltklima. In the 1850s, the founding director of Vienna's Central Institute for Meteorology, Karl Kreil, described the study of climate as a negotiation between micro and macro perspectives, between, quote, the world on the large scale and on the small. More than mere rhetoric, this principle was meant to regulate the organization of scientific work in the multinational state. At meetings of Habsburg learned societies, naturalists negotiated the value of their varied local perspectives relative to the goal of a synthetic overview. I refer to this process of negotiation as scaling, right? So that scaling is not just a matter of calculation, but a social process. Habsburg science was at its most generative when it provided conditions for scaling as an open-ended, ongoing process. The geologist and statesman Edvard Suess testified to the importance of scaling in the preface to a monumental physical atlas of the monarchy, which he co-authored with 3 colleagues, each responsible for a different region. He alerted readers, this is not a collective work. Just as each of the authors has collected his observations on his own journeys and has reached his conclusions independently, thus each has chosen to approach his account in his own way. And what is offered here is not one representation, but rather 4 representations in one shared frame. Suess was articulating the principle that philosophers of science today call pluralism. In fact, the foremost philosopher of scientific pluralism, Otto Neurath, grew up in Vienna when it was still the capital of the empire. Neurath's philosophy of pluralism reflected the Habsburg approach to the coordination of knowledge without recourse to a single overarching system, nor a hierarchy of explanations, nor even a common language. From the vantage point of today, the legacies of Habsburg science lie not only in the equations with which we model the atmosphere, not only in the philosophy of pluralism, but also in projects of scientific internationalism spearheaded by Habsburg scientists. Projects that continue to shape how we make and govern scientific knowledge today. The Habsburg states' supranational scientific institutions became models for the internationalization of science beyond its borders. Leading Habsburg scientists believed that the methods of collaboration and synthesis that worked within the monarchy could be scaled up to further the cause of worldwide scientific cooperation. So beginning with the first International Meteorological Congress, hosted in Vienna during the World's Fair of 1873, Austrian scientists led a series of endeavors to coordinate scientific research and natural resource management the world over. Among these, for instance, was the first International Polar Year of 1883, which aimed to round out the scientific picture of the Earth system in 3 dimensions. It grew from a proposal by Karl Weiprecht, a Habsburg naval officer who was critical of exclusionary nationalism and of voyages of exploration that served merely, in his words, the vanity of national flags. Driven by a vision of supranational science, Weiprecht set in motion a series of initiatives that eventually culminated in the International Geophysical Year of 1957 to 1958, right? The first systematic international effort to generate global data to model Earth systems, and in that sense, a direct predecessor to Eve. While these schemes did often prove to be Eurocentric and utopian, certain elements remain instructive today in the face of the present climate crisis. As we've seen, Habsburg scientists insisted that environmental research could not be left in the hands of nation states, nor could the use of natural resources be left to the whims of the market. At the same time, many of these scientists foresaw the dangers of globalization. Some warned of the dire toll that empire building could take on humans and nature alike, of the violence of a colonial Raubwirtschaft, or pillage economy. From a different angle, some of these thinkers questioned conservation measures that were no more than a cover for an empire's appropriation of land and resources at the expense of indigenous populations. Likewise, they argued that imperial policies designed to protect inhabitants from natural disasters must not become substitutes for addressing the inequalities that left some populations more vulnerable than others. Now, the work of scaling has been constitutive of the history of climate science, and as the Eve proposal suggests, it is vital to its future. Scaling is essential in part because global warming threatens the lives of communities who are drastically underrepresented in the highest echelons of international science. So today, the history of imperial royal science stands as a reminder that the problem of representing unity and diversity has no unique solution. Every solution inevitably masks some forms of difference at the expense of representing others. That's why climatology thrived on the institutionalized pluralism of Habsburg science, which generated skepticism from multiple standpoints toward every attempt at a synthetic overview. In the coming days, I look forward to thinking with you about how Eve might institutionalize pluralism in this sense. Rather than setting its goal as a global consciousness, a uniform consensus, how might Eve become a forum for knowledge exchange that respects difference? This is simultaneously an epistemic and a political challenge. Epistemically, the Habsburg principle of scientific pluralism holds that good science is science that can encompass multiple theories and methods. As Eve seeks to build one globally legitimate source of climate forecasts, how will it recognize other ways of knowing climate change? More specifically, how might Eve work in alliance with, rather than to the detriment of, local and indigenous systems of knowledge? Politically, the discussion document proposes to, quote, set the rules of the Confederation so as to ensure the global success of the project. But who will have the authority to define success globally? How will global success relate to success as defined by local communities? The lesson of Habsburg science is that success cannot and must not be defined once and for all. Process matters. What constitutes success must remain open to negotiation through an inclusive and equitable process. In this way, the work of scaling can serve both science and justice. Thank you.